What's up guys, welcome back to how to make a drawing pad on Roblox Studio part 2. In the last part we went over how to make this user input module, and we got it working. We tested the functionality with this local script and we saw that it was working fully. Before we begin doing anything in this part, I want to highlight some changes I made to this user input module. So here on the set enabled function, we had this part right here. If enabled equals this enabled parameter, then we do nothing and we set enable to the argument that was passed through this parameter. But I went ahead and added this, so if enabled equals nil, then enabled will automatically be set to true. So if you don't add an enabled value to this argument here, then by default it will enable it. And I also added this, so if you're disabling the user input controller, then it deactivates the mouse. So if you're clicking down on the mouse and it's disabled, then it'll basically send a signal as if you let go of the mouse button. So yeah, these are like the important changes I made to this module. I also added an API to it. See where I put the API. I didn't do it in the last video, but I went ahead and added it after that video was done. Like after I was done recording that video, I added this just to make it easier for myself. I usually do this for all my code, so yeah, just get used to seeing it, I guess. In this video, we're gonna be focusing on the actual drawing canvas itself. So this little frame right here in the middle, we're gonna make it so we can actually draw stuff in it. Like we can draw a line or a curved line. We just need to draw anything on it. So I'm gonna show you guys how to do it. And we're gonna be using this user input module a lot. I'm gonna make a class called, well, I'm gonna make a ModuleScript. I'm calling it a class because I'm so used to object-oriented programming. Alright, this ModuleScript, we're gonna call this DrawingCanvas. And let me just add some headers. Written by Briss, November 18th, 2022. And we'll just add the basic functionality of this module. So controls, drawing pads, and lets you draw on them. Alright, let's add an API section. Oh, whoops. That needs another dash. And we're ready to start coding on this. Before I start coding, I just want to let you guys know I'm gonna be doing some trigonometry in this part, because to do the lines, like to draw lines, you need to do some trigonometry to calculate the angle of rotation of that line, and you know how to calculate like the midpoint between 2 points, yeah, stuff like that. So it's gonna be some basic geometry and trigonometry, just letting you guys know, like in case you guys want to brush up on that, or honestly you guys could go into this part without knowing any of that because I'm gonna go over the math anyways, but just letting you guys know. Alright, starting with this drawing canvas module, you can see I created this drawing canvas table, and it has an index meta method called DrawingCanvas. And we set here in this DrawingCanvas.new function, we can call this a constructor, and we make a table called self, and we set the meta table of self to DrawingCanvas. So what this does right here is whenever we index anything inside this table, if it's nil, if what we indexed is nil inside this table, then it'll index everything inside this table. And inside this table we're gonna have functions that are related to this table right here. So you can call this object-oriented programming on Roblox. This is how I do it. I use this index meta method. I create a main table, and then I create a constructor inside this main table, and I create a new table and set the meta table of this new table to the drawing canvas table. That way every function inside this drawing canvas table is also going to be available to this table that we created. And then to add on to that, we can add properties to this table that we just created. So here I added a canvas frame, which is going to be the frame that holds all the brushstroke frames. Here I created 3 tables called brushstrokes, brushstroke history, and brushstroke undone history. The brushstrokes table is going to hold all the frames that we create, and these are going to be all the little brushstrokes that you see inside this screen right here. This brushstroke history is going to be, so when you're holding the mouse and you're moving the mouse, it's going to create a lot of tiny little brushstroke frames, and once we let go of that mouse, that's going to be one whole brushstroke history node. So we're going to add that whole list of brushstroke frames to this brushstroke history node, or to this brushstroke history table, sorry. And then this brushstroke undone history is going to be what we undo from this brushstroke history, so that we can keep track of that as well. Alright, now that we have this DrawingCanvas class, I went ahead and added this function isPointInCanvas, and then you give it a point, which is a vector2 value. Sorry, my dog is like destroying something in the background. But yeah, you add this point, this parameter. Oh my goodness. Okay, this DrawingCanvas class has this function called isPointInCanvas, and the parameter of this function is point, which is going to be a vector2 value, and it also returns a boolean. So we take the left corner and the right corner of this canvas frame, and if this canvas frame doesn't exist, then we're going to return false, because how can a point be inside a canvas that doesn't exist? So if it does exist, we're going to take the left corner and the right corner of that frame, and we're going to see if the point lies within the boundaries of that frame. And that's basically what we're doing right here in this return. So if it lies within the boundaries of this canvas frame, then we're going to return true, and if it doesn't, then it returns false. Okay, now we're at the part where we actually have to create the brush strokes to put them inside this canvas frame. And this is where we have to do a little bit of math and trigonometry. So let me just go over that real quick. Alright, we're on MS Paint here, and I made this little drawing right here, and this is going to be the basic problem we have when we're creating brush strokes. So let's say we have a position P0 and we have a position P1, and we create a brush stroke between those 2 points right here. This is the brush stroke that we're making right here, this little bar. Alright, well, with this problem right here, we have delta x and delta y because we have a difference in position, and we also have this delta p, which is the total difference between P1 and P0. So we can define delta p to be equal to P1 minus P0. Alright, and with this, we can also get delta x is equal to the x part of delta p. So we'll just do delta p, and then we'll subscript x. Then we do delta y is equal to delta p, and we're going to do subscript y. So now we have these two. We have delta x and delta y, but we need to know this angle right here, which is created by the difference between these two. We can get this angle by doing the tangent of delta y over delta x. Or, well, we can create an equation that relates this angle to the ratio of delta y and delta x. So we could do tan theta is equal to delta y over delta x. And you can see this is true because tangent is opposite over hypotenuse. So this is the opposite side of this triangle, and this is the adjacent side. Sorry, did I say hypotenuse? I meant opposite over adjacent. So it's opposite, and this is adjacent. So we have delta y over delta x, and this is going to be theta. So we can get theta by doing the inverse tangent. And we could do delta y over delta x. So now we have this angle theta. But to get it in programming, what we can do is, instead of using inverse tangent, we can do a tan 2. And this will give us a better calculation of this angle, because it'll take into account the signs of each of these delta y and delta x. So it's going to be a tan 2 delta y, comma, delta x. One more thing I need to note is when we have P0 and P1 and we want to get the rotation of this brush stroke right here, when we rotate frames, which this brush stroke is a frame, when we rotate frames, they go clockwise, they don't go counterclockwise like in traditional trigonometry problems. So what we're actually calculating for is negative theta. So all we have to do is put a negative in front of this atan. And now we can implement this into some code. So let's go ahead and do that. Oh, actually, before I forget, we should also calculate this midpoint right here. So let's add another point. Let's make it an orange. It's going to be a point in between these 2 points. And we're going to name this M. This is going to be the midpoint between P1 and P2. Or I mean P0 and P1, sorry. So we can calculate M by doing P0 plus P1, and then we divide that by 2. So it would be 1/2 P0 plus P1. And we could get this formula just from what we learned in geometry. The midpoint between 2 points is going to be that point plus this point divided by 2. It's kind of like the average of these 2 points. You can think of it like that. Alright, let's get to the actual coding now. Alright, so I went ahead and added this function called AddBrushStroke to this DrawingCanvas class. And the parameters are the size of the brushstroke, the color of the brushstroke, P0 and P1, which are both vector 2 values. And these are going to be the positions of where we're going to put the brushstroke. So here I made some variables: canvas position, canvas size, which is going to be the canvas frame itself, the canvas position, and the canvas size. Then we're going to have the displacement between these 2 points, P0 and P1. We're going to have the direction of this displacement, which is just going to be the unit vector of this displacement. So we're going to convert this vector right here into a unit vector. And then we're also going to have this midpoint vector, which is going to be the middle point between P0 and P1. And then we're going to have this rotation, which is going to be what we calculated before, that rotation of that brushstroke frame. And then we're also going to have this scale position, which is basically a vector that has the percentage. It's basically like a percentage. Think of it that way. It's the percentage of that canvas frame. So let me just show you guys, just to make it visual. So let's say we have a frame inside this canvas frame. Right here, the scale position of this frame is 0 because we're at the 0% of this frame. And if we were to change it to 50%, it would move to the middle right here. So let's do that. So right here we can do position, and we have X, and we can see that we have scale and offset. So offset is the size in pixels of this entire frame, and scale is the percentage of this frame. So let's set it to 0.5, and you can see that we move this frame to the middle. This left side of this frame is in the middle of this bigger frame, which is what it's inside of. It's easier to calculate this scale position rather than this offset, because if we were to calculate this offset, we'd have to calculate the entire position of the main frame. So this main frame up here, and then we'd have to do it relative to this little frame, which is where we're drawing on. So it's easier to just take that percentage of this frame. So let's calculate that percentage. And the question now is, how do we actually calculate the scale position? Well, to make things easier, let's first look at how we can calculate a percentage of any 2 numbers. Any 3 numbers, actually. Let me just show you guys what I mean. Okay, let's say we have 2 points, and we're gonna write them. We're gonna do A, and this is gonna be 0. So for the x-axis, this number is gonna be A, and it's gonna be positioned at y equals 0. So A and 0. Now we also have B, and we're going to do 1. So we can think of this as A being 0% of an interval, and we can think of B as being 100% of a certain interval, and that interval is between A and B. So let's do A and B. This is going to be the interval. And we know A is 0% of that interval and B is 1% of that interval. So what if we have a point X? How can we get the percentage of this X between the interval A and B? And that's basically what we're going to be calculating here. So what we can do is calculate the slope between these 2 points right here. So let's do that. Let's do y2 minus y1, 1 minus 0, over, and then we can do x2 minus x1. So we do b minus a. Here we get 1 over b minus a, and that's going to be our slope. So let's do m. Actually, let's not do m. Let's do r in this case. So r, we're going to describe that as the rate. We're going to do 1 minus 0 over b minus a, and we get 1 over b minus a. This is going to be the slope of this interval right here. Now, how do we get p from a arbitrary number x? P has to be the percentage of this x number between this interval a and b. So we can do, what we can do to get this p right here is turn this into slope intercept form, I think it's what it's called. But to do that, we have to do p minus, let's do 1. P minus 1 equals slope 1 over b minus a, and then we have x minus b. Actually, to make this simpler, let's use this point right here. Let's use a and 0. So p minus 0 over x minus a. Let me just make that a little clearer. So p minus 0, x minus a. And the reason I'm using a and 0 is because p minus 0 is just p. So we have p already simplified for us. And we have 1 over b minus a and whatever's inside this parentheses. So x minus a. And sorry my handwriting is so bad. I'm trying to like draw this on a computer. It's kind of hard. Let me just make this a little larger. Alright, and now we can just simplify this expression to get p. So we do p minus, so p equals, and we can simplify this by distributing this to this. So we have x over b minus a minus a over b minus a. And we can simplify this even further to equal x minus a over b minus a. And that's going to be equal to p. So now we have our formula. P equals x minus a over b minus a. And this is how we get the percentage of x in between the interval a and b. So now that we have this calculation for the percentage, let's go back to the code and actually implement this. Alright, so going back to this AddBrushStroke function, I added a scale size and scale position. And what we do is just get the percentage of this size, the size that the frame is going to be in pixels, and then we just turn it into a percentage based on the size of the canvas. So we start at vector 2.0 for A, and then we do canvas size for B, and then we do something similar for the scale position. So we put the midpoint as X, we put the canvas position as A, and we put canvas position plus canvas size as B, and that way it'll give us a percentage for this midpoint in between the canvas position and the canvas position plus the canvas size. And one more thing, I took off the negative for A10 because I just remembered that when you're using when you're positioning any sort of UI element in Roblox, it actually starts from 0, 0, and 0, 0 starts from all the way up here. So it starts from this top left corner, and then as you go further in the x-axis, it goes to the right, and as you go further in the y-axis, it goes down. So instead of going up when y is positive, it actually goes down, and it goes up when y is negative. So we start at 0, 0 here, we go up in y, and we go down in the screen. So to counteract that, I did a negative, or you could do a negative here. You could still do negative atan2 and then just put displacement.y as negative, because the displacement between those two positions in the y-axis is going to be negative because of that small detail of UI elements. So this should still work, but this should also still work. And then we turn this rotation into degrees down here, because this rotation is going to be in radians. atan2 returns a radian, like a rotation in radians. So we just have to convert it into degrees. And you can see that I put atan2 in degrees up here. I just did that so I don't have to type math.deg and math.atan2, just because it looks better like this. And here we made the frame, and we add it to the table of brush strokes. And now we should have a working brushstroke thing, creator thing, yeah. And then we also have this percentage function, which is what we went over in Microsoft Paint. So xab, and we return x minus a over b minus a. Now we want to make sure that the drawing canvas actually works. So what I did here is I got the DrawingCanvas module, I required it up here. And you can see that the DrawingCanvas module is still inside the screen GUI. So what you want to do is localscript.parent.drawingcanvas. That's what I did here. We required this, and then we created a new drawing canvas. And what we did is we added the drawing pad frame, this drawing pad frame right here, as the argument to this constructor. So now we made a new drawing canvas called main canvas. And we also added two variables called brushstroke size and brushstroke color. And that's so we can set the brushstroke size and the brushstroke color of the brushstrokes we're about to make in this main canvas. And right here, when we activate the tool, we want to add a brushstroke at that initial position. So what we do here is we add brushstroke, this main canvas, this colon, add brushstroke, and then we do brushstroke size, brushstroke color, and then the current position twice, because we're just making a dot. And then here, on this render step function, we also added this last position. So when you activate the tool, it creates this dot at the current position that you activated the mouse at. And when you move it, it also sets the last position to this last position variable. And we set the current position to the actual position. And we do that by adding delta to this current position. So now we have the last position and the current position of the mouse. And we can add a brushstroke between the last position and the current position. And that's exactly what we do right here. So every time we move the mouse, it creates a brushstroke between the last position and current position. And we should see accurate brushstrokes on the screen now. So let's test this out. Alright, now let's go ahead and test this out. And you can see that when I move my mouse, it actually creates the brushstrokes exactly as I wanted them to be. So now we have an actual drawing pad. Like, we have the drawing pad done. Let's go! Time for celebration, I guess. I don't really know. This is a really early, I don't know, a really early version of this drawing pad. We're gonna add a lot more to this. So we're not done yet, but we are done with the main thing. Alright, so that's going to be the end of this video. Hopefully you found it useful or helpful. In this video, all we did was create this drawing canvas module, and we made a constructor, this constructor right here, drawingcanvas.new, and the argument to this constructor is a canvas frame, but you don't necessarily have to have a canvas frame. You can create a new drawing canvas without a canvas frame. And then we also have these brushstroke these three tables for brushstrokes, brushstroke history, and brushstroke undone history, and we're going to use those later, maybe in part 3. We have this function isPoint in Canvas, and that just tells us whether this point that we add as an argument to this function is actually in the canvas frame, is within those canvas frame, like within that canvas frame, sorry. And then we also have this percentage function, which we went over, and this AddBrushStroke function, which adds brushstrokes to the screen. And I think that's all we need to do for this part. So leave a like, comment if you found this useful, subscribe if you found this useful. I'm gonna be making a part 3 soon, which I'm gonna go over a lot of other stuff, a lot of more technical stuff. This is like visual stuff, mostly visual and math stuff. Yeah, so that's it, guys. Thanks for watching, and I'll see you in the next one. Bye.